my name is Kaylyn Chapman. In this video, we will be discussing how to calculate the heat transfer. We will do this in 3 simple steps. 1. Calculate the change in temperature. 2. Use equation Q equals mc delta T. 3. Divide by moles of the substance. And 4. Flip the sign. Now let's break down the equation Q equals mc delta T. Q is the heat measured in joules. M is mass measured in grams. C is the specific heat capacity. That is measured in joules per gram times degrees Celsius or joules per gram times K. Delta T is the change in temperature. You find the change in temperature by subtracting T initial from T final. For our first example problem, we are using an example from a previous video that showed how to use a calorimeter. For our first example, we used 10 milliliters of water and we used 3 grams of calcium chloride. So our first step for solving this problem is to find the change in temperature. So our T initial was 19 degrees Celsius and our T final was 23 degrees Celsius. To find our change in T, we're going to do T final minus T initial. So that would be 23 minus 19, which gives us 4 degrees Celsius. Our next step is to use equation Q equals mc delta T. So we just calculated delta T to be 4 degrees Celsius. Now we have to determine what M and C are. C would be the specific heat of water, which is 4.18 joules per gram times degrees Celsius. Now M. So we're given our milliliters and we're given grams. But since we're using the specific heat of water, we're going to have to turn our milliliters into grams for our mass. 10 milliliters of water equals 10 grams of water. So that gives us M being 10 grams H2O. So now we can plug in these numbers to the equation. So we have Q equals 10 grams times 4.18 joules per gram degrees Celsius times 4 degrees Celsius. So we will multiply this through and we get 167.2. Now we can figure out the units. So we see that we have grams here and grams here, so that means they cancel out. We can also cancel out degrees Celsius. So then we're left with joules. So this is 167.2 joules. After solving for Q, our next step is to divide by moles of calcium chloride. So we're given grams of calcium chloride, so we have to convert the grams to moles. So we're given 3 grams CaCl2 over 1 mole. And we're going to take the molar mass of calcium chloride, which is 110.98 grams per 1 mole. So now we're going to divide 3 grams by 110.98 grams. And that leaves us with 0.027 moles of CaCl2. So now that we have the moles of CaCl2, we can plug it into this. So now we can divide by our moles. So that gives us 167.2 joules divided by 0.027 moles. That gives us 6192.59 joules per mole. Now we will divide this by 1,000 so we can get kilojoules per mole, because that's how it's normally written in the literature. So that gives us 6.19259 kilojoules per mole. And our last step is to flip the sign. So that means we give it a negative sign. So our answer is negative 6.19259 kilojoules per mole. And we can round that to negative 6.2 kilojoules per mole. For our next example, we will be using 10 milliliters of water and 3 grams of ammonium nitrate. As mentioned before, the 10 milliliters can be transferred to 10 grams of H2O. So our first step is to calculate the change in T. T initial was 20 degrees Celsius. T final was 4.6 degrees Celsius. So to find the change in T, we do T final minus T initial. That gives us 4.6 minus 20, which is negative 15.4 degrees Celsius. So now that we have our change in T, we will use the equation Q equals mc delta T. Just like before, we'll be using C equals 4.18 joules per gram degrees Celsius. And our mass is going to be 10 grams of H2O. So now we plug that in, we get Q equals 10 grams H2O times 4.18 joules per gram degrees Celsius times negative 15.4 degrees Celsius. We will multiply this through and get negative 643.72. So same thing, we cancel out what we can cancel out, and we're left with joules. So the next step is to divide by the moles of ammonium nitrate. In order to calculate the moles of ammonium nitrate, we will take the 3 grams, put over 1 mole, and we'll use the molar mass of ammonium nitrate, which is 80.043 grams per 1 mole. We will divide the 3 grams by the molar mass, and that gives us 0.0375 moles of ammonium nitrate. So now we have the moles, we can plug the moles into this. We can divide our Q by the moles of the substance. When we divide that, we get 17165.86 joules per mole. As mentioned before, the literature normally has it in kilojoules, so we will divide by 1,000, and that gives us negative 17.16586 kilojoules per mole. So our last step is to flip the sign. So we are left with positive 17.2 kilojoules per mole. That is our final answer. When we have a positive answer, that means that heat is transferred to the system. When we have a negative answer, that means that the system lost heat. Thank you. That is it for this video. If you would like to learn more, go check out our other videos.